Hi, Shruti. Good morning.
I was unmuted and I muted myself. Hello,
Okay, hi. Good morning.
how are you doing, Sammy?
Good. How are you?
Good, good.
Did you guys get a cold blast?
Sorry.
Cold weather?
Yeah,
Did you
I'm
guys get
cold.
affected? Or?
You can tell. Yeah, I'm having
Okay.
cold.
No, cold weather.
Oh, cold weather. Um, Here it is okay. I mean, I'm in California, Sacramento, so
Okay.
not so much. I'm not in Seattle. Yeah, Seattle area is having quite a bit of a fight. But yeah,
Right. Even icy now, still our roads here.
are you in Portland?
Correct, yeah. Yeah, hopefully today afternoon get cleared.
So very quick question, Sammy. So
Yes, go
last
ahead.
week I was not able to attend your session. Um, did you folks already sort of present and get feedback from Eric?
So Eric is supposed to go yesterday, I believe, yesterday morning.
Okay.
I didn't get feedback from him whether what happened there. So my understanding was there is a TGG meeting
Yeah.
yesterday morning, and he said he's going to be bringing up this topic with them.
Okay.
And I believe the way he told me was he's going to kind of preview the things going to come, and it's going to be scheduled for next week or week after to have a discussion. The discussion probably not
Oh, I
last week
see.
itself.
Okay, so the discussion wasn't scheduled for yesterday either.
No, he's going to bring it as open there for a discussion to schedule a slot.
Okay.
And I think at the time when it's getting scheduled, he said he might invite me, depending on what they're asking there. So
Okay.
yeah, I will sync up with him and let you know. Yeah. Hi, Kobe. Good morning. And see someone joined over the phone.
Yeah, good morning, Sammy.
Good morning. I'm on.
Sammy, I might step out for a second. One of the neighbors just hit his car on
Oh, so given I say like next to my road, like the whoever parked, is slided and hit another car.
Yeah, see, they're all very confident to come up on the flat portion, and the car just slid right back down.
I know. Yeah, it's really it's the worst.
Hi,
Yeah,
Sammy,
I think
this
it's
is
because
Gopi.
it's black.
Yeah.
They think it's a road. It's not road. It's ice.
Oh.
Yeah, thankfully I avoided. Like yesterday evening, I was planning to go out, and within like 15 minutes, it's all frozen up. Luckily, I was home.
You folks having black like sheet ice everywhere?
Yeah, we have black ice now.
Yeah.
I think what happened was there's a cold front came now it blasted like heavy wind with the cold air, and it froze within like 15 minutes. I can see, and the trees, right? It's just like a big blast, and it's frozen the whole thing. Even my windows right now, like I can see like big puddle of ice sitting there.
Oh, that's terrible,
Right.
Be safe, that's important.
Yeah,
Hello, everyone, this is Gopi. Yeah.
Yeah. Hi, Gopi. Yeah, thank you. So I think, yeah, Shruti, I will get Eric's input and keep you updated.
Yeah. But likely that is another 2 weeks away then, right? That's what we're saying.
Correct. Yeah.
Okay.
Yeah. And also, I think last week, Jeff presented the profile, what is the OCP profile? What is the concepts available and what are the different pointers. I think there's a lot of tons of information already available. We have to go and spend some time to really harvest all the things related to sustainability, what is already available, and we need to summarize it. And we took an probably 2 weeks from last week to come back and give a report out. Any other opens today?
No, I don't have any. No?
If not, what I was thinking is today, let's circle back on the IUE definition that we had and start working on going to the next level details there. We want to kind of start getting some alignment here. So I put few slides for starting the discussion. Let me kind of share the slide here. So as you know, all of us, right, like even the white paper for the PE that we wrote is kind of pointing to there's a lot of problems that need to be addressed, especially and how do we account for infrastructure side? How do we divide the power given to the computing portion versus the non-computing portion, right? That is the one we really want to work on it, right? I think it's fair, right? I think from PE side, they assumed anything given to IT side, it's all consumed for IT work. But now we want to go and enhance it. I think that's a thing we want to work on it now. So the way I'm kind of thinking is we should look at system level in IUE. Once you have a system level, I'm saying multiple devices and components, then we will go next level, like what does that means here, right? You can have fans, you can have CPUs and cooling, different, all the components we need to account for. Then once let's go and look at this a little bit more detail. And the assumption is if we get a system level, in rack really contains multiple systems, and it can be network, storage, anything, whatever you want, right? Plus you could have additional power supply cooling related items. Then if we expand it further, DC contains multiple racks and power supply cooling, or maybe we should put some, I don't know, infrastructures for whatever, maybe some storage or whatever additional we want to account, right? I believe there was a new word they use, right? That we really need to account for it, right? Anything we should include at a high level on the IE? Then if I go to the system, at least 3 big buckets I see from the work here, right? One is idle power. How do you want to account? Then cooling related, how do you want to account? And power related. I believe we also talked about WE and how do we account for it? Maybe I will add it. Or impact or any other things we should be looking at it?
Yeah, that covers everything. Yeah.
Yeah. So thank you. Now, this is again at a high level, we summarize it. I want to kind of go back and re-review and see whether any adjustment need to be made, right? So at a high level, we are saying data center has IT power and non-IT power and a bucket. Then if you look further, what we can say is each hardware, IT hardware power, and IT power and IT cooling. These are, I believe, this one does not really represent the picture very well. I think we need to kind of add the some additional things here. I think what we said was the compute power is total server power minus thermal loss minus power conversion loss minus ideal losses. These three items we said we can think of total IT power. Once you know the active power and total compute power, you get a IUE. And also we talked about this can be computational power can be 0. We need to flip it so that always you're going to have active power. Computational power can be 0 in this case. Let us first kind of align on that. How do you want to?
Question.
Yeah.
Sorry, actually, we have looked at all these formulae earlier. So the question is not with that. I just noticed. So in the figure above, on the rightmost part of the figure, when you're showing the IT hardware power, IT cooling, and IT power, what does that slice try to show in the figure? The IT power slice right here.
Yeah, I think that's what I mentioned when I was talking, right? So our IT power loss probably, right?
Oh, that is the loss. Okay.
Yeah, that is
Right.
the loss. That's not
Okay.
I think it's there. It's because Shami, when the formats changed, I think the text got shrunk or something. So anyway, it's lost.
Right.
Okay.
Yeah, so there is a certain amount of DC to DC converter losses once you're inside the IT hardware.
Yeah.
Right.
Probably,
Like
yeah.
the formula below. I mean, we went over the formula where.
Yeah, exactly. We've done that
all
before.
figure losses.
Exactly. Right.
Yeah, I think now I'm coming back because we said we should consider. I want to come back here and say like, hey, can we say this is what we want to finally recommend, right? That's one of the reasons I want to have a discussions today, right? So this one, I think my question here, do we want to flip this for the purpose here, right? Because we know computational can be 0. If I'm running at ideal
idle losses will never be 0, Sami. So you can never have a divide by 0 here.
Yeah.
Idle loss being 0. That's one of the reasons we put idle losses in there, because you can never get this the denominator to 0.
Infinity. Yeah.
No, what I'm saying is, if we are running an ideal
at idle, it's in undefined. Remember, the next slide says that.
Yeah.
Correct. What I'm saying is, at ideal, this is going to be become undefined, right?
Yes, exactly.
Yeah.
My question is, do we want to flip it so that we can put a computational power on top and active power on the bottom?
Yeah, it becomes a ratio. It will become a percentage.
Ratio. Yeah. Correct.
Yeah.
Right.
You could do that.
Because we want to. Let me put it or make a note here, right? If we are all aligned, that's what we want to go. Let's say IUE is flipping this formula here, right?
Yeah. Yes, I mean, you're saying like PU could have been defined as efficiency ratio in some sense.
Yeah.
Yeah, they say 1 by PUE is efficiency.
Yeah,
right?
exactly. Yeah, precisely.
Right.
And you're saying let's go to efficiency because it's never zero, no matter what.
Correct.
I mean, you never have the divide by zero problem and exceptions and all that.
Correct. Correct.
Yeah, you could define it that way, but it'll be a 0 to 100 type thing.
Correct. You can either 0 to 1 or 0 to 100, right? If you multiply by 100, it's a 0 to 100.
Yeah.
0 to 100, yeah. So because you're going to multiply by 100, yeah. Yeah.
Stamping it does not allow me to switch, or I can just say computers. Exactly. So then the load is 0 to 100, right? That's what you want to
Yeah.
get,
Okay.
get
Definitely.
it, right?
Yeah. You're trying to avoid having a divide by zero problem ever.
Correct.
What you're
Correct.
trying to do. Okay.
Correct.
Yeah, I think then it will be symmetric with PUE, but that's fine. Right.
Yeah, we can always put. We need to. Yeah, correct. Yeah. PE also defines that it is you can do 1 by PE to get a factor, but people that is not really like many people are not using it, right? They're not communicating in terms of efficiency. They're communicating in terms of what is the PE number, right? In fact, we talked about in that paper also about that. What I want to do. So let's see if we are okay with that. Then let's go to the ideal power. How do we want to account for it, right? So what is the definition of ideal power you want to have?
One more quick question, Sami. Every time we, write active power, like system active power, or whether it is the server level, every time we write active power, we just mean the total system power, right? When it is running at that particular load.
Correct. Yeah. What we are saying is, yeah, what is power consumed by the system?
Yeah.
Because you don't want to put TDP or you don't want to put ideal, because you can say system ideal power. It basically means it's no system in ideal state, right?
Yeah.
TDP basically says I have max powerfully consumed. Active is at it's basically power consumed at load. Think of
At
that
that
way.
load.
Right. So now let's go one by one, right? I think I want to kind of look at all the three items here, right? Ideal power. What we want to define? Do we want to define that no workloads system is booted and no workloads running, or we want to say because it's all depending on the scheduler, right? Or you're going to have still some OS services will be running, but not really running a customer workload per se, right? Infrastructure workload might be still running. We need kind of make it little more clear on exactly what we are meaning by idle power, right?
Idle power is when there is no load on your system, right?
The server, yeah, that's about it.
No, I got
Seymour, say what's the issue?
so more like when you still have OS running, that means it's going to do some infrastructure service agents might be still running, right? Are we considering idle power as when we say no workload is running? Do we consider infrastructure workloads as a ideal workload? Or do we say that is part of the IT energy?
There'll be some
see-
level of management services and other things will be running, right? So no application is running. That's about no processor utilization in a way, kind of, right? Just like a spec power load line 0 to 100, right? So
right. We have to define that weightings, right? So that people are aligned on that, right? When we say ideal power, what are we including, right?
Oh, I see. You want a tight definition of idle power.
Correct, right.
Okay. So I guess let me. You're asking, what's the definition of no load? Is what you're asking?
Correct.
Okay.
Right.
Okay.
System booted. Infrastructure services. No. Customer workload or applications running.
Yeah, there is no useful work being done by the system, right? There is no.
Yeah.
So if you think of it, nobody's active. I mean, it's essentially sitting around delivering no useful work. That's
useful
idle.
work. Yeah.
So system booted, infrastructure services running. No.
Yeah.
I'm trying to still tighten it so that we makes it clear, right? No applications. It's still infrastructure, maybe some written as applications, right? In cases, right?
Yeah.
Somebody may be polling some sensor data, whatever it is, some minimal level, right? So
right.
Sorry, go ahead, man.
What we mean, there is no customer workload running.
No, I don't want to say customer. It's we want to put some wording. Basically, what we are indicating is, at the end of the day, it is not really delivering a what do you call services, right?
Is that really your definition, Sammy? So to me, okay. So I think I can see what Shruti said because she's sitting in Microsoft. That is exactly the definition for Microsoft.
Right.
But so as a hardware person, our definition would be that you're not making demands on my processor to fill instructions beyond a certain rate. Right? That's why I'm idle, because you're not sending me any instructions.
Correct. Then
when you say
let's define
system
that.
is idle, when you say system is idle, you're really saying the computing resources in the system are idle. And you are getting to why is it idle? I'm saying, well, I don't care. You're not issuing enough instructions for me to do any real work. So I can actually enter some power saving mode.
Power state, right? Right. That means nothing at all, even infrastructure services are not running, right?
Right.
No, infrastructures are there, but they're not crossing a threshold, Sammy, right? So infrastructure is basically, waking up and seeing, is there some work schedule? Nothing. Okay, go back to sleep. Wakes up. There is a timer loop that's running. So
correct.
Yeah.
So you can't say infrastructure is not running. How would you have an OS without having a preemptive multitasking going on? He has to wake up on the timer loop.
Correct. So what we want to say it so that we want to make it clear, right? I think that's what I'm kind of looking for, right?
Okay. So the scheduling queue of the underlying operating system continues to stay empty. That's really what's happening. So you're not scheduling any work, and therefore nothing is getting done. So am I spending a few cycles here and there? Yes, of course I am.
No work is scheduled?
Yeah, no work is being scheduled on the processor's computing elements. I would say processing elements because you don't want to say threads or cores because that's very specific to our architecture or somebody's architecture.
And then,
so yeah.
And then when you say infra services running, you're literally just saying that idle detection might be the only kind of service running, right? In infra services.
You still need to run something so that are we totally asleep or are we keep on periodically waking up and checking something and going back, right? That's what I'm trying to. We want to edit, right?
Yeah, I'm also asking the same thing. Then you're saying that infra services means idle detection is the only kind of infra service running.
Right. Process anything else? I'm trying to see what do we want to put it so that people can understand when we say ideal power, what that means, right? Ideal detection. Anything else? And put a question mark so that we can circle back again. Is there anything else we have to put it in the wording, right? No work schedule on processing element. And people can argue this is the ideal detection itself also some work schedule, but other than ideal detection, that's what you're meaning here, right? Anything else that let's go back here, right? Is there anything what happened? Losses thermal plotted, okay. Yeah, I think we comprehended here everything related to that. So
one more thing, actually. Yeah. So if there is, telemetry reads happening, then right. Is that considered not idle?
It's all depending on, right? If you read the telemetry from out of band, system can be still idle.
Right? Yeah. So suppose it is not out of band. So in case, yeah.
Yeah, so we want to keep that as ideal, right? Because it's not delivering any useful things to the thing, right? We want to say telemetry or system health collection is not really providing services, right? It's just keeping the infrastructure ready. So that's how do we want to?
Yeah, that's not part of the compute cycle in a way.
Correct.
Right? So it's just checking the health and then leave it there, right? Does it, nothing else. Other additional things may come into, is there any security, attack going on? You may go back and check and go back to sleep. That's about it, right? So it's just, those are basic entities you run as a service.
How do you want to tighten it up? For ideal power, some level of system health and data collection may be allowed, right?
Yeah.
But if you want to still differentiate between, I'm collecting too much. When you're running a application or workload, you might be collecting more, right? That you want to keep it under the IT infrastructure power or compute power. On the ideal side, whatever you're collecting, you want to say that is part of ideal power, right?
Yeah.
Okay, let me put the thing when we finally weight it, we need to figure out how do we weight it, right? Let me, okay. A good point, Sriti. Anything else? And so then I think going back onto the two things we need to kind of start looking, right? This is defined. How do you operationalize, right? That's what one more thing we want to figure out, right? How does one know that system is consuming idle power? What is the metrics you have to use, right? Do we assume today? I don't think it is reported as idle power by the BMC or a system, right? Do we want to include some metrics or status from processor side or something so that it BMC knows here is a idle power?
BMC is not going to know this, Savvy.
Lowest level, right? So you can go back and see what the
Because
P
you don't
states.
know what.
Yeah.
Yeah, remember this is the age-old problem. You don't know what work
Mm.
is being scheduled. You can just look at the side effect. So let's, instead of saying BMC, let's say out of band. Can you detect the instruction completion rate? Maybe, I don't know. It's very hardware-centric question that you're asking at that point. But instead of saying BMC or whatever, like, can one detect it? Of course, right? Because that's, if you don't detect it, how does power management even kick in?
Yeah.
Sammy, why do you worry? Because are you worried that people are gonna do? You can't report it lower than it is, correct?
No, but
You
I'm
can report
looking
it
more
higher. Yeah.
But I'm looking more like who's going to report this number? How is that going to be generated?
Okay.
I have to detect it, right? So that if we can say PMC, when you got the system ready, we may probably put a fixed number, right? Computed number or measured and finally populated a number to the BMC. The other way is it can I dynamically detect you are in ideal state and report it, right? I'm trying to see what is how do you operationalize it? Can we use a static number? If we say static, that means basically saying every time when you develop a system, put the system in ideal state and compute it, and you just populate the number to give it the number to BMC, right? And in this case, what are the assumptions on the IO devices? Is it only compute is not done, network still streaming to the memory? Can anything else can be in progress or?
Yeah, you need to look at all the devices populated in the server, right? It can be CPU, memory, GPU cards, accelerators, whatever the case may be, everything, right? So holistically, you need to look at it to see that they are all in idle, right, states.
And one thing, this idle definition then means that if there is any background process happening, like if there is scrubbing going on or garbage collection going on, from the hardware's point of view, that is not idle.
No, that's still ideal because
Well,
it is not doing any useful work, right? It is just keeping the system healthy.
but then we basically just said no work scheduled. Like how would the hardware, know that this is garbage collection and not useful work submission?
Yeah, that's right. You cannot know this from sitting in sitting in the hardware world. Hardware world can only know this by Shruti. We can still know based on the some issue rate, right? We know in, like, for example, in silicon, and I'm not just saying we. When I say we, I don't just mean Intel, whether it's AMD or Intel or Ampere or whatever. We know the number of instructions that are being retired per second, and maybe there is a metric there to say, it's below a threshold.
Okay, that might be the case. I'm not sure if that is a clear,
Yeah.
for sure we will be able to say by number of instructions.
Again, I think Sammy's opening up a can of worms here on this issue, right? There's a lot. It is definitely hardware centric, because at the end of the day, at a certain threshold, the hardware is going to kick in its power saving features. For example, in some sense, the way like the timing loop works, or the scheduling loop works, is that if there is no work, it doesn't sit and hold continuously. That will be a criminal waste of power, right? Especially all of us sitting in sustainability group, we shouldn't allow that, and they don't do that. And then in the good old days, they used to go to halt. They used to just issue the halt instruction, and then any interrupt will wake it up, which including the timer interrupt. But now there are better power management mechanisms. So we don't know, because the scheduler actively helps you by saying, I got nothing here. Don't waste energy. Go into a sleep, some kind of a core level sleep state.
Sure, but that is when it will be able to go that if there is no background work scheduled also, like the scrubbing or garbage collection, and nothing of that is scheduled also.
Well, so I think, again, software versus hardware. I don't know what you guys mean when you say memory scrub, because Shruti, there is something called a patrol memory scrub. That's a hardware engine that just independently runs all the time, 24 hours a day. If you're saying that, Shruti is basically thinking more like if it's a Java and you're doing garbage collection.
Oh, okay.
Yeah,
So
let's
you
say
gotta
garbage
say,
collection there. That's fine. Maybe that is better, understood here. So if there is garbage collection running, do we want to call that time as idle time or not?
no, it's not idle time, because you're waking up, causing spurts of activity, and then going back to doing nothing. While you're running garbage collection, it's not idle.
Because cycles are consumed at that point,
Yeah,
so you cannot.
It look like an ECG, right? It'll just spike, silent, and then spike and silent.
Okay. Then what is the memory scrub that you have listed here?
It's a hardware feature where the memory controller sits and continuously looks at every memory, even if you're not if software or the cores are not accessing it. It looks at every memory location once every 24 hours.
It's basically to see any error happen.
Errors, yeah. It's a RAS feature. It's a RAS feature. Yeah.
And also like a refresh, all those things are happening in the background, right? Memory refresh, because capacitors need to be charged periodically, things like that, right?
That's self-refresh.
Right.
Self-refresh that's going on. Yeah.
Right.
Okay.
Yeah. So that is one.
I mean, you make her a hardware person, she'll make you a software person. There you go.
Okay, got it.
That's what's happening here.
So the another area is how do you account the smart NIC in BMC? Because we can move a lot of compute power to, keep the compute idle, the processor idle, but a lot of smart NIC might be still doing a lot more work.
No,
and BMC,
I wouldn't put BMC and smart NIC in the same breath. Remember, BMC is supplied by the aux rail.
Right.
Smart NIC is supplied by the primary rails of power.
Right.
So smart NIC, it's just like any other IO device. It's part of your IO device accounting. So if you're alive, stuff is coming in, it's getting processed. but nothing is crossing a threshold for you to go wake up the system. So again, I think the trouble that we are having here, Sammy, is that what is strictly idle is when you're doing no work, but it is really not that simple, because you're gonna have this spiky thing going on, right? You're gonna wake up, do some work, go back to sleep, go wake up, go do some work. But if you take a average over that period, you're not you're not crossing a threshold for how much activity is happening in the system.
Right.
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 I, I I don't know how. So I don't know how to do this in any way without bringing in processor power management. And I can bring in processor power management. In fact, I can show you how this all works for Xeon, but we need a solution we need an answer that's common across, right? And I don't know what
Yeah.
that answer is for the other processors right now. So let me go look into that first.
Yeah, I think, but what I'm kind of trying to bring here, Mohan, is when we say system, it
Yeah.
has one main core processor,
Mhm.
plus SmartNIC is running another processor. It is doing something similar to what the compute, but it's doing a different type of services.
Mhm.
BMC is another processor is doing something similar, right? Do we say these things, guys, need to be idle state, or they can be active state, but it is not really like it's only main processor we concerned, right? Or do we want to even account something here, right?
They could be actively receiving traffic, but they're not really opening. They're not really causing the processing elements to wake up and do something. So this is so you're kind of getting to the origins of idle power. Why do we have so let's just talk system idle power, right? If you're doing no useful work, why is the system idle power not zero? That's really the question, because I can't do that, right? So
Right,
even
right.
when, I mean, it's kind of like when say power off to your DVR or whatever device you have. It's not off, because if I truly go off, you can't wake it up with a remote call. Some circuit has to stay alive for me to receive and wake up again. So in case of a server, SmartNIC, timers, all kinds of these interruptible devices are going to stay alive and consume power, and that becomes your baseline for idle power consumption, right? That is where you're literally getting your idle power from. The fact that SmartNIC is consuming power, the smart or NIC is consuming power, the fact that some of your IO chips are consuming power, the fact your memory is consuming power.
Is it
Right.
something we need to define the threshold itself? Because when the compute is being used, the computer memory, there's always a spike. And then if you say within a percentage guardrail, if it is there, it is not, it's pretty much idle in a way.
All of this is consuming power, yet no useful work is being done.
Yeah, definitely, sure. Yeah.
I think that's correct, but I'm also trying to see how do we operationalize, right? How do we say this is a number that we want to say it, right? Because my worry, Mohan, is CPU becomes orchestrator, right? The remaining guys really consume a lot more power than CPU. Then how are you going to account there, right? Do you say other guys are not delivering a useful thing, or how are we going to account, right? For example, GPUs can be consuming a lot more power. And even in idle, they probably never shut off. They will be consuming a lot more power. So then if you're just looking at main CPU's power, it may be idle, but others guys are still consuming power, right?
Yeah, and that's what I'm trying to figure out, Semi. So what's your?
I mean, if they say I'm just thinking, right? If you have the CPU and GPU, and then CPU is the one is going to do an offload to the GPU and later on workload. CPU is involved in some way or the other, right? That means it's consuming power. That means it is not idle in a way, right?
If you do whole thing is IO based accesses, you don't really need to ask CPU to do work. You can still you're doing a lot more computing going on in background without really waking up CPUs, right? Okay, at least for this area, we have enough data. Let me kind of rewade and work and see how the definition we want to align on it. And also start thinking about it, right? How do you want to account for the IO device power consumption there? I mean, one thing is, if it is traditional mode, that means when the CPU goes to idle, nobody else is supposed to be consuming a lot more power. But old is expanding, right? Like a lot of SmartNICs is taking over a lot of CPU related work. And same thing, GPU is doing a lot more CPU related work. Now, they may be busy at a certain level, still processing, or can be offloaded from remote CPU to these guys. I just want to kind of make sure that we can put some wording that comprehends that, right? Okay, I think we. Anything else comes to picture that we should be accounting in ideal side? Otherwise, we'll just move on to the cooling. We want to do the cooling or power. I think power probably easier topic. We have only 10 more minutes. Then we can come to cooling. So power side.
Sorry, Sammy. I was just looking up. First of all, by the way, Energy Star tried to look at idle power and they said it's too hard. Forget it. Let's just focus on saving energy. But then there is a Linux definition of idle power. I will send it to you and maybe you can just use that. Okay. That will be common across our CPUs. I know exactly what's idle for us at Intel, Sammy. I just don't know how to. Yeah.
At system level, what do you do, right?
Yeah, let's take the Linux definition because it's common across.
Okay.
I'll send you the link. Go ahead. Go with your.
Okay. So cooling, we have multiple different areas. We will come back probably next week. Now, if you look at the rack, the power, right? There's two ways. We have 2 or 3 different ways, right? One is each system has its own power supply, and the processing unit consumes power, and from power supply you have a converter from AC to DC, or then also DC conversion. Both are having losses here, PSU loss and DC to DC conversion loss. Then you're really running the remaining system. Another way is you could have a PSUs outside the system, and it's supplying a DC bus bar. Is still going to have a DC losses there. If you are going at a system level definition for this one, since you are saying it's outside, system may look more efficient. But when you populate at a rack level, it comprehends the whole thing. In this case, yeah, system level includes all the 3. So when we go to system level, do you want to just make sure that only we comprehending system level, or we don't want to put any percentage for the PSU there? Is that okay, or what is it thinking?
Say it again, Sammy. What's the difference between the server 1, server 2, server N?
So this one
yeah, there is PSU, no PSU. I got that part.
Yeah. So you're accounting these losses as part of system.
Yeah.
PSU losses. In this world, you're not accounting PSU losses. You're only accounting DC to DC losses.
That's right.
So when you compare with the traditional one compared to DC will look better.
Right.
But when you look at rack level, it may be equal or slightly better. Its rack is consuming this losses, right?
Mm-hmm.
So my question is, do we want to just follow this definition and say like how much power is consumed by server and minus the DC losses is server power? Is that good enough definition?
No, I thought we covered this, Sammy. I thought we have a definition at a server level and at a rack level. And at a rack level, you will essentially apportion the rack level PSU conversion loss to each of the servers in the rack. Correct?
That's true. I think that's what we had. I'm kind of what is the percentage you want to put, right? I think that's
Oh, you want to pick all controversial topics today? Okay.
because we
so
need to tighten it, right? That's the reason I'm kind of bringing it back here, right?
So then it becomes, so really the question is, it's across all the servers and then
Correct.
it's weighted average. And your question is, what's the weight?
Correct.
Yeah, the weight has to be proportionate to the power you consume.
So it's basically TDP per se, because you in a server you could have multiple different TDP servers populated, right, in a rack.
Exactly. See, because the conversion. So I wouldn't like let's talk about the rack level PSU. I wouldn't be the amount I'm losing is proportionate to the amount of power that you are demanding from me. And if you like let's say there are two servers, make things simple. One guy is demanding 10,000 watts and the other guy is demanding 1,000 watts. And so total 11,000 watts is being demanded of the PSU. So the conversion loss, whatever that is, you demanded 10,000 watts, so you get more of the penalty of this thing.
So it is at the consumption level or
no, whatever you drew, whatever is your power draw, it's proportionate. The weight, that's your weight.
Right. Okay.
The power draw, your power draw divided by the total power consumed at the rack level, that ratio is the weight of what we are going to.
So without knowing rack level, I cannot compute a system level.
No, you can. System level, you can always go talk to your PSMI and it will tell you, but you cannot do this. You cannot attribute the rack level losses to your system without knowing the rack level power.
That's what I'm saying. Like I cannot give IUE for a system unless I know rack level what is my person I'm consuming it, right?
Yeah.
So okay.
Yeah, exactly, Sammy. Yeah, you cannot.
Right.
Yeah, there will be rack level efficiency, the losses, and then what goes to each and every system, the summation of all these will give you the in a way, right?
Yeah. Right. Yeah, definitely. There is a problem there. I mean, there's not a problem. Yeah, you have to get it. And yeah, that power supply will be plumbed to give you that support.
Okay. So it's basically as a rack, I'm basically distributing this PSU to individual systems. As long as I aggregate system level, I will get the rack level, right? I don't need to consider the power supply as a separate component from a rack perspective. Since it's amortized across all the servers, right? So I think the reason I was kind of looking at it is when we do the IUE per system level, if I just aggregate them, is it good enough? Or even I need to have an account for a PSU loss separately in this case? Because there is a power conversion loss, right, at PSU level. Yeah, if you are putting a factor that works, then probably we'll go with that. But once Let me put that factor and let's make sure that we align on that definition that we can go there.
Yeah, I think that's the fair way.
Right.
Instead of just doing unweighted average across everybody.
Correct. Okay. It's a total. I mean, your total TDP for the rack, and you have each system's TDP is there, and you know how much you want to. How much you are consuming. You can go with the factor there. That factor has to be communicated from the rack to system level, or you need to combine both in order to finally get the. I'm kind of looking also operationalizing it, right? That's the reason I'm kind of want to have the conversation there.
I think in the previous model, what we developed, we accounted
Right.
from the rack, the losses and
Right.
system level losses and all those things were factored in, if I remember. I can look through that, Yeah.
Right. Okay.
And
Okay.
so
Yeah.
one clarification there. Now for the system level is essentially made up of multiple racks. It is also made up of multiple servers which are sitting in that rack. Are we trying to approach it as we sort of see it as a summation of all the servers and not see it as a summation of these racks?
Now, when we say DC, it's summation of multiple racks. But if we are looking at a rack, it's a summation of servers. You're
So,
not going across a rack.
so if you go to your slide 36, there you are looking within one rack.
Correct.
Is that right? And then you want
Correct.
to sum multiple racks to the system.
For the DC, multiple racks. This is a server. This is a rack. And
Yeah.
the same thing, the previous one, this also rack. Rack power.
Yeah.
This is system level power.
Semi, I got to jump. I will follow up.
Okay. Yeah, I think it's 9 o'clock anyway. I also need to jump. Thank you, Tim. We'll continue the discussion next week for the coding side. I
Okay,
will.
sounds good. Yeah.
I will bring in a kind of summary of this one next week. Yeah.
Okay, great. Thanks.
Thank you.
Good. Thank you, Tim. We'll talk to you next week.